Hi guys, yeah, we'll start the session now. Shivani, you're there?
Yes, ma'am. Hello, all.
Shivani, you're connected on another phone. Can you please turn off the audio of that?
Yes, ma'am.
You can start on Shivani.
Ma'am, is it clear now?
Yeah, it is.
Yes, ma'am. Hello, all. Good evening. Welcome to free webinar on offshore structure and SACS. HIW, Hyderabad Institute of Empowering Engineers, is a premier educational and training institution dedicated to nurturing the next generation of engineering talent. HIW focuses on bridging the gap between academic knowledge and industry requirements by offering hands-on training, skill development program, and real-world project experience. With a mission to empower aspiring engineers through innovation, driven learning, and mentorship, HIW fosters a dynamic environment where students can grow technically and professionally to meet the challenges of the evolving engineering landscape. Let us welcome Mr. Hari Prasad, an experienced trainer and accomplished offshore structural engineer. He holds a BTech degree in civil engineering and has over a decade of hands-on industry experience. Mr. Hari Prasad has worked on numerous complex offshore projects across different regions. He is passionate about sharing practical knowledge and bridging the gap between academic and industry. Without any further delay, I would like to hand it over to Mr. Hari Prasad, who will take us through today's session and share his expertise. Hari Prasad, sir, over to you.
Yeah, thank you, Shivani. Yeah, good evening, all. This is Hari Prasad Gaddam. Uh, I'm working as a offshore structural engineering. So, can we start the session?
Yeah, you can, Hari. Please go on.
Yeah. So, we can see that title of our webinar is Building Beyond the Shore: Introduction to Offshore Engineering and SACS. So, building beyond the shore, we can see that all we have studied diploma or engineering, we haven't heard about this offshore engineering. It haven't included in our syllabus, but there is a much scope in that. So we can discuss about that. So what it includes in our this webinar. So overview of offshore structures and the introduction to the SAC software used in their analysis. So are you excited? Tell me in the text. Are you excited? Yeah, okay. Let's go to the next slide. So what is offshore engineering? So in a diploma or in BTech, we just see buildings and beams, columns, soil, steel sector. We have all discussed about these things, but we haven't discussed about the offshore engineering and in diploma and BTech in our Telangana and Andhra colleges. So, what is offshore engineering? Offshore engineering involves the design, construction, and maintenance of structures in marine environment. So, it's all about beyond the land. Like we have to handle the things on the sea or ocean surfaces. So, we have to build and design, construct the offshore structures over the sea. Okay. So, importance of offshore structures. What offshore structures do? So we used to have oil and gas extraction is the main things, major concern and major thing we do on offshore structures. Then we recently there is a more scope of renewable energy and communication and maritime infrastructure is building over the offshore, and we're using more seaways as the main platforms to build the energy. So these structures should build like a to it should withstand in the harsh environment of waves, wind, and seismic. So what we do in this actually, so offshore structure, what we why we are building these things to extract the fuel and to produce the renewable energy and for communication. And we can see that our broadband connections are those go through the under the shore. So these are the things we do by building the offshore structures. Next, so what are the type of offshore structures? Platforms, compliance towers, semi-submersibles, FPSOs, spar platforms. So we know that we haven't heard these mostly. Uh, we haven't heard these. What are these structure? Fixed platforms, compliant towers, semi-submersible. What they do and why they build, how they build. What are the things we conclude? What are the things we have to know how to build these things? So this will be a much interesting session for you, and this will be add on much valuable session for you guys. So be excited. So these are the types of structures in offshore. So we can see that the first one, fixed platform. So there are we can see like six types of platforms. So first one is fixed platform. So fixed platform name itself is showing like it is fixed, it won't move. And these structures we build for only 1500 feet, up to the depth of 1500 feet. So these structures what do means like digging the oil from the sea or ocean and extracting it. All the major purpose of these types of structures is to dig the oil and gas. So we can see like the first one is a fixed platform. It is depth up to the 1500. If the seabed depth is crossing more than 1500 feet, then we are going to the compliant tower. So these tower is also there is a limit for it. It is 1500 to 3000 feet. Beyond that, we can't go with that because the harsh environment of the ocean or sea, it won't be like it won't stand in that. Next one is a sea star. This is from 500 to 3500 feet. We can prefer this one be except like fixed and compliant towers is between 0 to 1500, 1500 to 3000. This sea star is 500 to 3000 because it is like a floating platform. There is a like a buoyancy force will be there. There are pontoons under it, so there will be due to the beyond buoyant force, it will withstand in the ocean. Next one is a floating production system. We can call it as a FPSO, floating production systems and operations. These will up to the 1500 to 6000 feet depth of sea. And next one is a tension leg platform. We can call it an TLP in a shortcut. This like it is in between 1500 to 7000 feet. Next one is a subsea system. Subsea system is like there is a underground missions will be there, and those will extract the uh, oil from the sea, and those will transfer to the shore onshore. And next will be the spare platform. It is between 2000 to 10,000 feet. Okay. Next, key components of offshore platforms. So we got to know that in before slide, what are the types of offshore structures, and we can see images of that. So what are the components included in that? So we can call it the jacket, topsides, deck, risers, conductors, heli deck. We can see like these are the main components of the offshore platform structures. So we can discuss further what is the purpose of each component. So by the image, we can see that I think you have seen in some movies or somewhere like these kind of structures. So these plays a crucial days in a crucial role in our daily days. Like we used to have like a fuel we need. fuel for the regular purpose. So these are the platforms beyond that to extract the oil. So you can see first it is a deck on top side. It is consisting of the major equipment, machineries like electrical equipment, mechanical equipment, instrumentations. So all those are rest over the sea level. Next, this is sea level. Beyond the below that, there is a jacket. We can call it as a jacket, which is supporting the top side deck. This is the thing supports the top side deck. This is sea floor, well conductors. This is oil and gas below the soil. And this jacket structure is resting on the piling inside. We can, I think, we'll listen in our diploma and BTech that piling structures will be there. So these are the main things for the fixed platform. Next one. So fixed versus floating platforms. So we have seen that fixed platform before we have seen this is the fixed platform. And what is the difference between the fixed platform and floating platform? We have seen that by increasing the depth of the sea, if the depth of the sea is increasing, we can't go to the fixed platform. Okay, so what is the difference between the fixed and floating platforms? So fixed platforms, they can't move. They're in a fixed position. And floating platforms contains of the moored structures, and the mooring means like threads or ropes. We can call it in a simple manner. We can call it as a mooring ropes or threads. So they will tie to the seabed to control the movement of the platform over the sea level. I hope you understand. Next, what is the life cycle of offshore projects? So we got to know that what is offshore structures, what is offshore engineering, and what are the types of offshore platforms, and the difference between the fixed platform and floating platform. So what is the life cycle of offshore project? If you have taken offshore project, uh, first thing is like concept. Concept in the sense what we are going to do, what kind of project you are going to do, what is the purpose of it. That is the concept. Feed means of front end engineering and the design. Front end engineering and design. So after the concept, we go to the feed. So the in feed, we get to know that what type of structures we are going to build, what type of structures we are going to design, and the preliminary overview of the plant or project you get to know in the feed structure, feed stage. Next, detailed design. After completing the concept, we get to the feed. That is a feed in the sense like overview of the structure, project. Next, detailed design. Detailed design in the sense we see like we have designed in the diploma or BTech, like we just design small structures like uh, buildings. We can see that in the in-depth for the particular load and particular condition, we design such particular beam size of beam. So in that type, like in detail design, we give to the drawings and design. Then after designing and drawings, they are sent to the fabrication. So fabrication will build the structure, then it will be the installation. There is the next stage. Installation to the operation, operation to the decommissioning. These are the stages involved, 8 stages involved in the life cycle of the project. These are the common in offshore and onshore. Next, design considerations. I think, are you understanding? Have you any doubts? Like, yeah. The design considerations, we are much aware of the design considerations, the environmental loads, structural integrity, material safety, and economics. So we can, by picture, we are seeing dead load, live load, environmental load, accidental load. So we know what are the dead loads we can consider in the offshore structure. Just imagine in sea, what are the dead loads will be there. Dead loads in the sense like equipment load, instrumentation load will be there on the platform. Next, live load. Live load in the sense like vibrations of the equipment. If there are any humans, like man will be there to uh, operate it, then environmental loads. So major concern, a major difference for the onshore and offshore structure is environmental load. Here we in environmental load there is a waves and wind. In offshore, there is a huge impact of the wave loads and wind loads. Those are the governing loads on the structure. Next, accidental load. Accidental load in the sense blast, or if any ship got impacted to the platform. Those are the accidental loads we consider. And by using these four loads, we used to combine and apply to the structure. Next. So we can detailedly discuss like what is environmental loads included in offshore structures. First thing is wind, wave, current, seismic, and ice loads considered in the design. Okay. So these five types will be the major environmental loads we can consider, and these environmental loads we can't like there is a particular procedure to extract how much wave height will be there, how much impact of that wave, and how much velocity of that. So all those considerations will be taken to apply the load. So, and seismic, we know that depending upon the zone, there will be different types of seismic zones, and it depends on the seismic zone. There will be impact of that on structure. Next, structural loads and fatigue. So, what are the structural loads? We have discussed like before dead load, live load, environmental load, and accidental load, and how we going to deal with these loads. So before we have seen like there is a load combination we are getting from the dead load, live load, environmental load, and accidental load. These are the we are combination in the sense if the dead load and environmental load is getting once, and the live load and accidental load is getting once, and all four combined getting once. So there which is having more impact. So that we are going to apply in the structure, and let it that decide the structure strength and sizes of the members. So here we can see load combinations, and next up material properties, support conditions. The material properties and support conditions are the basics in our engineering, like what type of material you're using, and the yield strength of it, and size of it, diameter of it, length and breadth of it. So those are the material properties and support conditions. These are the basic in our engineering support condition, the fixed condition, pinned condition, roller condition. What are the support conditions you're going to give? And next, soil characteristics. In even it is in the offshore, the structure, if it is a fixed structure, it is going to rest on the soil. If it is a floating structure, we don't bother about the soil characteristics. Soil characteristics in the sense what kind of soil it is, what is the safe bearing capacity of that soil, and how much depth we have to drive the pile to get the stable strength. And next, water depth. uh, we have seen that like up to 1500 we can go for the fixed platforms, and then all combining these loads and properties, soil and water depth, we're going to analyze the structure. After analyzing the structure, what we got to know, major things we are going to check is like a stress. What is the maximum stress we are getting on the structure or member? If it is a limit, if it is a crossing the limit of the stress, then we are going to increase the size of the member. Understood. So this is basic engineering, like we do, like we are applying some load and we are checking the strength of it. If it is a passing for that load, then we are going remaining that. If not, we are going increase the size of this member. Then that is the checking of the stress. Then deflection. If you take some beam like structure, okay. So if you are applying load on it, there is tend to the some deflection for that. Deflection should be in the within limits. Okay. Then member design and a joint design. So after getting the stress should be in within limits and deflection should be within limits, then we are going to design the member. Then we are going to design the joint. Okay. So these will be much interesting when we are going to do this. And with these are the codes and standards. We used to actually in our education curriculum, we only have that IS standard codes, Indian standard codes. But in offshore engineering, we are mostly using European codes and American codes. Those are the most interesting thing will be there when you're getting to know that American codes and European codes. Next. So, what are the types of offshore analysis we are going to do? So, generally, in our curriculum, we're not aware of that. What are the kind of analysis uh, these particular kind of analysis will be do or not. Then, so we can go through the what are the types of offshore analysis includes in place, fatigue, seismic, dynamic, collapse, and transportation analysis. I think we got to know that like only seismic transportation analysis, by the name, we can say that these should structure should they remain for these loads. So, but major thing like in here, like I think you might listen these all these words for the first time, but while doing it will be much interesting. Okay, yeah. So we can see by in short way like what are the types of analysis we are going to do and what it means, like a load out analysis. So we have seen that in stages of the structure in a project, like we have seen that first concept, feed, and the detailed design, then fabrication, right? So after the fabrication, our analysis going to start. What happens after the fabrication? We have to transfer the structure to the sea. Okay, so for that, load out analysis is going to carry, but means from the fabrication yard to we have to shift it to the ship. So for that, we call it as a load out analysis. Okay, for that, what will happen while shifting? There will be some uh, total only there will be the only dead weight of the structure, and there will be some movement of the crane. So those things are we are going to consider on our structure, so that we are going to analyze that the structure will be safe while loading out to the ship. Next, transportation analysis. Transportation analysis in the sense like after getting into the structure getting into the ship, that we are going to carry that structure to the where it is going to place. So while transporting, there will be some movement like wave movement and a wind movement. So for that, the structure should withstand without failure. For that, we are going to analyze the structure and lift and launch analysis. So after reaching the ship to the place, we have to lift it and launch it to place it in the it is a fixed position. For that, while lifting, there will the same like it will the same as some like load out condition. We are going to some difference in like here there is some like hooks will be there so while lifting it. So for that, the structure is withstanding for that lifting and launching. Next, appending. Appending and launch will be like same. We are if you imagine like some jacket like structure, I will show you. This jacket structure. So this structure, while we're moving from ship to into the water, there will be some movement or some rollers. We have to keep that rollers under the jacket. So the while moving there, while appending it to the sea, there will be some for that some stress will be created on the members. For that also the structure should withstand. And next on bottom stability analysis. So first the structure will be on the horizontal. If you see the jacket, the structure while carrying it will be the horizontal. Here it is like it will be more than 40, 50 to 20 to 120 meter it will be there. So it will be in horizontal while carrying on the ship. Okay. So that we are appending means like we are keeping it the straight position. For that there will be some one kind of analysis and pile drivability analysis. So these are the analysis, pre-service analysis. Before placing the jacket, where these analyses are going to carry on the structure. Next, in-service analysis. After the jacket is first fabricated and we have transported it and we have placed it in the structure, we placed in the place. It's a fixed position. Then on that, we are going to the in-place analysis. After is fixing it, we are going to consider in-place analysis, earthquake analysis, fatigue analysis, ship impact analysis, pushover analysis, cathodic, and opportunity analysis. So in short way, we can say that in-place analysis in the sense, uh, the jacket structure. I will show the image. Just imagine this is the structure. It got placed in the ocean, and all the equipment is placed on that. All the ultimate load we are going to consider, and waves will be there on that. So for that, we can say that this wave loading is a typical load. Like we used to say 1 year, 100 year, 1,000 year, and 2,000 year waves will be maximum loads we are going to consider. So for that, our jacket structure should withstand for that load. So in place in the sense, like after placing it in the fixed position, all the maximum loads we are considering wind load, wave load, and these loads are considering for that structure is withstanding or not. That is called the in-place analysis. Next one, like earthquake analysis. Earthquake analysis, we can say like by the name we can say for in oceans there will be much impact of earthquake. We can know that tsunamis will occur in the ocean due to the earthquake. So for that kind of earthquake loads and vibration, structure should withstand. Next to fatigue analysis. So I think fatigue in the sense I think you might not listen what is a fatigue. We got to know in the general term fatigue means it got tired. Okay, here it is in fatigue means repetitive loads. I think in concrete we can say that creep fracture. I think just say anyone have you hear about creep failure? Creep failure. Have you listened about the creep failure? Uh, into yes, yes. So the fatigue is like a same continuous loading is occurring on it, then it tends to fail. So for that continuous loads in a repetitive way, what is the and how many years it will take to get failure? So here we are testing the in fatigue analysis, we are going to test the life of the structure and then ship impact analysis. But just imagine that structure and one ship is going to hit the jacket. For that, ship should withstand for the impact of the ship. So that we are going to analyze the structure should is going to withstand for the ship impact. Next, pushover analysis. Pushover analysis, we can say that uh, in our engineering, we can say that we have designed retaining walls. Retaining walls. So for that, there is a overturning check will be there. How many of you aware of overturning check for um retaining walls? Just confirm me that are you aware of that overturning check? Anyone? Yeah. So overturning in the sense like structure is all the horizontal loads are getting for horizontal loads or vertical load should be dominating for that horizontal load. Structure should not get overturned. We can say that a push over means the waves are horizontal loads. If they are pushing, the structure should not fall. So we are checking with a major horizontal loads, and for that our structure is standing or not. And then cathodic protection analysis. So cathodic protection in the sense we know that in ocean there is a more tend to have corrosion for the steel structure. So for that we are using cathodes. Cathodes protects the structure, jacket structure from the corrosion. So we are going to analyze cathode protection for the jacket. Next, opportunences analysis. Opportunences analysis in the sense like for jacket we have seen like uh, only not only these kind of structure. For that we can see here like some vertical members here. Those are called conductors, J tubes, and wellheads. So what these do? So these jacket is in just supporting the top side, but conductors, J tubes will do like they are like a boring. Will the will be like a bore under the seabed, and we are digging the oil. So they used to protect that wells and cables. Those are the appurtenances analysis. So next, after that, we pre-analysis is done, and in service analysis we have done. Next, asset integrity and inspection. Asset integrity in the sense if our structure is placed and it is going to service and it is going to operate. So after few months or few years, we have to make inspect it. Is it working properly? It should there should be some regular inspection should carry, so we can call it the asset integrity. If the structure is built before or 20 years back. Okay. So for that, we are going to inspect the structure. How many years it going to withstand? So some few assessments we have to do for that, and is it safe or not? Those are the asset integrity and inspection. Next, so role of the structural engineers. So we got to know what is offshore engineering, what are the structure will be there in offshore, and what kind of analysis will be there, what are the loads we are going to consider, how we are going to analysis. We got to know that there's some preliminary idea on that. So what are our role, what we are going to do. So they perform so design, analysis, review, and inspection planning. So these are the things we are going to do while doing a project. Next, we at least we got some idea or knowledge on that offshore structures and how we are going to design it, how we are going to analyze it. The main tool we are using and which is a more trending tool we are in using in the offshore engineering is SACS. So what is this SACS? SACS, it is an engineering software for analyzing the structure and design the offshore structures. Okay. So in SACS interface, the after modeling the structure, this is how we can see. First one is the jacket structure. and second one the compliant tower, and this is the wind turbine, and this is the FPSO. It looks like a ship. Uh, so all the analysis we are going to carry on this SAC software, and which is more demanding software in offshore engineering. Importance of SACS. So we know that like widely using software in the offshore industry, and it is a more capabilities compared to the other softwares. Okay. So the what kind of structures we can design and analyze in the SACS software. So we know like before STAD you might listen in your engineering, AutoCAD you might listen in the engineering, E-tabs, but I think most of the people don't know what is the SACS software. Okay, because there is no scope for the in our curriculum to get to know all these offshore engineering things and knowledge. So next, structural analysis for the top sides and a jacket. We got to know jacket is the structure which is built beyond the sea level, and the top side is the above the sea level. And next, those are the in top side and jacket we can call it the fixed platform and the compliant tower. Top sides are the TLPs, semi-submersibles, spars, and FPSO. These four are the floating platforms. And we can motions and stability analysis we are going to do. All these kind of structures we are going to design in the SACS and analyze the for what are the pre-service and the in-service analysis. Here, this is some kind of image you can see how SACS interface looks like and the structure, how it looks like after modeling. Uh, I will show you that how SACS interface will be there. And we have discussed like in analysis we are going to carry in this SACS. Uh, in place analysis we have discussed in the preliminary these are we are going to check the structure stability for static environmental and operational loads. Next to fatigue analysis. Fatigue analysis, like we have discussed, like before I have said that the creep load. Okay, so same like a creep failure. So same like that, we are going to uh, check the damage due to cyclic loading using SN curves and the stress ranges. Okay, like SN curves means stress curves. So C state and wave load generation. Uh, I've told like that for in particular place and particular region, there will be different types of waves and a different height of waves will be there, different velocity of waves will be there, depending upon the region and place. So for that, where we are going to construct that structure, for that we have to consider the separate sea state loads and wave loads. And first of all, we have to consider the what type of loads we are getting, impact of loads. Then we are going to apply those loads to the structure. Next, pushover and collapse analysis. Before we have discussed like pushover in the sense overturning of the structure. For the extreme loads, for the extreme horizontal loads, is it withstanding in its position or it's a tilting? We are going to check in the pushover analysis that behavior of the structure. Next, jacket launch and lift analysis. So for that, first we have discussed like jacket launch in the sense we get to know by name after fabrication. We are taking that jacket structure through ship to its place, and we're going to launch to place it its place. So before launching, we are going to lift it by the cranes. For that lifting, is it withstanding and those stress limits of those members are going in being in within limits or not? Those we are going to check. And spectral and time history analysis. Spectral and time history analysis is like same fatigue analysis. Those are same, similar names, synonyms, so we can say that. So, uh, spectral analysis or fatigue analysis, like we are going to say that for the repetitive loads and dynamic loads, the structure is withstanding or not. So only thing is by SACS or whatever the structural software, what we are going to do is basic idea is like forget loads for in the particular place there will be some particular loads. For that loads, our structure is withstanding or not. That is the major thing where structural engineers do. So in that way, if we are going in deep, there it is a magic will be, we can feel as a engineer. Okay, next. So interface, what SACS do? I think we know STAD and AutoCAD, right? So we can model the our structure in the STAD and AutoCAD. We can directly import it to the SACS also. There is that convenience for our SACS software. And how workflow in the software will go. First, we are going to model the structure. Like first, we are going to if you some people might aware of the stat, we they got to know like first we are going to create nodes and then members. So in that way, we are going to model a particular structure. What we decide. Then after modeling that structure, we are going to analysis. Analysis, we have seen that pre-analysis and post-analysis, almost like 9 or 10 analysis we are going to do for that particular structure, because all those extreme conditions of environmental loads and dead loads, it should withstand without failure. After analyzing, we are going to code check. We know that for most of the offshore structures we are using American codes and European codes. Indian codes are we are not there is no scope for the oil and gas offshore structures. And after that, we're going to generate the report. Next, what is the career scope for offshore engineering, and what kind of companies will be there? How will be the career, and how much demand for this like offshore structural engineering? We can discuss. Like SACS is the most demanding offshore software. So EPC, consulting, and oil and gas industry, there is a wide range of uses of SACS. So we can see in image like these are the top 15 companies: Saudi Aramco, ExxonMobil, Chevron. You can take a screenshot of it. And these are the top 15 companies which you can offer good packages but after learning this SACS software and offshore engineering. Yeah, that's the session. Hope you guys liked it. You you can ask if you have any doubts. Any doubts? Structures, Tarun, structures saturated in the present competitive job market. Uh, Actually, there is a huge demand for the offshore structures engineering. Uh, you can, if you got well aware of that SACS and offshore engineering, there is a much demanding for that. Actually, Yeah, do offshore engineering projects impact the marine environment? I no, actually, there is a some protocols and safety they used to follow. You might listen that there is some accidents like oil leakage in the shore offshore, like in oceans and seas. There won't be much impact on that. We are going to follow that safety norms, all those protocols. They after following that norms and safety concern only, the government will give you the permission to the build the structure. So there won't be impact for the marine environment. Yeah, that's it. And there is a good job market for the offshore engineering. Yeah, that I can say. Uh, any more those tax interface? Yeah. I will show you. Yeah, this is the how SACS interface looks like. Uh, First, these will be the main interface, home settings, projects, and it is same looks like our STAD only. If you are aware about that, it will be different, but all our softwares functions like a same options will be there like interface. Uh, So here you can say interactive like modeler data file viewer is yeah, hull modeler means just modeler means like we can see the directly a jacket I have said like jacket will be modeled in modeler and hull modeler means you know that ships like Titanic, right? So those we can analyze, those we can design in this SAC software. There will be separate engineers for the hull modeling. Uh, so if we go to this is the jacket structure. Okay. So these horizontal things we can see, these are the top side we can call it. These are all those equipment loads we can consider as a loads on it. Uh, Bottom one is uh, jacket. This one is all about 30 meters of platform. We can call it as a offshore platform. And this one is the boat landing. Boat land. We have seen that the ship impact analysis, right? So for that ship impact analysis, there will be this. We are going to provide this kind of structure to reduce the impact of the ship on this jacket structure. So here on top side, where this is like a very small platform I'm showing to you. There will be huge platforms will be there, and this is a very small platform. And on this, there are some. Uh, okay, I will show you after after completion of this interface introduction. I will show you a few images of how offshore structures will be there. Uh, and how we are going to model it means here it is a joint, right? So we are going to add joints. After creating joints, after in between joints, we are going to add members, plates, and after that, we're going to give properties for that members. Okay, by this, we're going to give like how much diameter, thickness of the members, and load properties. Like this is a joint load or member loads. If you're aware about of stat, then you might understand this how it interface looks like, and then load, weight, environment, environment I've seen like all corrosion, marine growth. They after installing the jacket platform in the ocean, there will be some marine growth on it, like leeches, grass, uh, all will be grown on the. So for that also there will be some impact on the structure. So that also we are going to consider on the structure, and there is a corrosion that also we're going to consider, and the windshields, uh, all the sea state loads we are going to consider on it. All options will be available in this. So, so for designing a structure, we know that like first we get to know what how structure should be there. So in that way, in that input, we are going to model the structure. Then after modeling it, we are going to apply the loads on it. Loads like dead loads and live loads first. Then dead loads like equipment loads will be the major things in offshore. And live loads means like human loads, where we can take it as a 2.5 kilonewton per meter. We are going to apply on the uh, free areas or structure. Okay. Then after applying loads, we are going to give properties and sections for the members, and then wind loads and wave loads we are going to give. After applying all those loads, there will be some load combinations. Okay, so by taking those load combinations, we are going to design the members. So if in case, like I will tell you, mm, mm, if our structure is like that, and this is the sea level, and this is the top side. Okay. So we are getting dead load in vertical direction, and wave loads and wind loads in horizontal direction, and there will be seismic vibrations and live loads. So by combining all those loads, there will be maximum stress occurring on the some particular member you are going to design. For that stress, we get to know we have to provide some particular size of member. Okay, so this is how we are going to design the member. Okay, uh, I think this will be the preliminary, like a basic introduction to the SAC software. By learning you, it will be much interesting to learn, and too good. And because how I can say it will be interesting means where you are going to deal with the natural forces, and so that will be much interesting to know. I will show you some uh, pictures of offshore structures. Yeah, real-time images. Yeah, here you can see and see how it is like same. This is a double deck. Before I have shown in the SACS is a single deck. Here it is a double deck. It will it's like a some like house that big it will be there. And here you can see some other structure and this one. This one is the only jacket without top side. And see how big those jacket legs. See how small human looks like. And you can Google it or you can do some YouTube to get aware of those. It will be much interesting to know all those. Yeah, that's it. Yeah, okay, I'm going to stop sharing. Ask me if you have any doubts. Do offshore renewable energy sources can capture wind and tidal power? Yeah, offshore renewable energy sources like question from Vikas. Uh, you know that wind turbines, right? You might have seen on shore, on land. So those going to capture the renewable energies of wind and tidal power too. There will be some particular structures for that. That also we can do in offshore engineering. When compared with designing steel and RCC structures, offshore had a demand, but I'm asking overall in the present situation, structural engineering position gets more pay. Still have a BM engineer due to BM implementation, the projects are structure saturated. That is the thing I'm asking, not specifically about offshore. Overall, what do you say, sir, about the structural engineering? Yeah. So I can say that compared to the BIM, structural engineer has a more demand in the market, job market. So in overall, you can say that whatever the steel, RCC or offshore structural engineer has more demand compared to the BIM engineer. On first slide, it, okay, I will share your screen again. First slide, it is like a title of the our session. Do you want that? If you want that presentation, I will share to you to you later. Any more questions?
Hi guys, any questions? I could see no as an answer. So a small announcement, guys. We have a batch starting on May 22nd on civil structural design, wherein you will be learning various industry used applications along with the industry aspects on real-time case studies. So the message has been shared on the chat box. You can get more information on it from the chat box. You can also call our team for more details in that. So please do give the feedback. You will be receiving certificate once you fill the feedback. It will be onto your email ID. Um, any questions, guys? Okay. Thank you, Hari. Thank you for your time.
Yeah, thank you, Bhavya.
Yeah. Thanks, guys. So we'll get back to you on this in a detailed way. Thank you so much. Have a good day. Guys, for the fee structure, you can contact our numbers that are being shared on the group. Our team will get back to you on the fee structure and other details. Thank you so much.